You've probably asked this question a million times, maybe as a kid, maybe just last week, and you probably think you know the answer. But what if I told you that the classic textbook explanation is only half the story? The real reason is so much cooler.
Right? It seems like such a simple question about the world around us. And look, there is a simple answer, but it leaves out a huge, fascinating detail. The complete answer tells us just as much about ourselves and how we see the world as it does about the sky itself.
Okay, so let's start with the part you probably remember from science class. It all begins with sunlight, which, as you know, is basically a big mix of all the colors of the rainbow all hitting our atmosphere at once.
Now, our air is packed with tiny, tiny molecules, mostly nitrogen and oxygen, that are way smaller than the wavelengths of light. When sunlight slams into these little molecules, the light gets bounced around in all directions. This whole effect is called Rayleigh scattering, named after the guy who first studied it. But here's the crucial part. It doesn't scatter all the colors equally. Not even close.
Okay, this looks a little technical, but the takeaway is pretty simple. Shorter wavelengths of light get scattered way more than longer ones. So blue light, with its short wavelength, gets bounced around about 10 times more than red light does. All that scattered blue light comes at our eyes from every direction. And boom, the whole sky looks blue. Simple, right? Well, here's the twist. This is where the simple, classic explanation starts to show some cracks. And honestly, this is where it gets really, really interesting. Seriously, think about it. Violet light has an even shorter wavelength than blue light. So based on everything we just said about Rayleigh scattering, it should be scattered even more than the blue light is. Our sky should be a deep, rich violet. But it's not. So what's going on? To solve this little mystery, we have to stop looking up and start looking inward. Because the missing piece of this puzzle isn't about physics at all. It's about biology. It's about how we are literally built to see the universe. All right, let's do a super quick tour of the amazing biological tech inside your head that turns simple light into the experience of color. So when light comes into your eye, it gets focused on the retina, which is this layer at the very back. Now, the retina is covered in millions of these incredible little cells called photoreceptors. They're basically tiny light detectors, and their job is to turn light into electrical signals that your brain can actually understand. When it comes to color, the most important of these cells are the cones, and we have three types. We call them S, M, and L cones for short, medium, and long wavelengths. Every single color you've ever seen in your entire life is just your brain mixing and matching the signals from these three types of cells. That's it. And this chart right here, this is the solution to our violet mystery. These curves show how sensitive each of our cones is to different colors. Now, look closely. Our blue S cones, they do see violet light, sure, but they actually get most excited by blue light. And on top of that, our eyes as a whole are just kind of less sensitive to violet. So even though there's a ton of violet light getting scattered up there, our eyes are just way, way better at picking up the blue. So here's the big takeaway. The color of the sky isn't some simple fact of physics. No, it's actually a partnership, a collaboration between the atmosphere and our own biology. Let's dig into how that amazing partnership really works. Okay, first, you got to get your head around this super cool concept called metermerism. Your brain doesn't actually see all the different wavelengths of light hitting it. It just sees the final combined signal from your three cone cells. So get this, you can show your eye a pure single wavelength of yellow light, or you can show it a very specific mix of red and green light. And guess what? Your cones fire in the exact same way. Your brain literally cannot tell the difference. It just sees yellow both times. And that is exactly what's happening when you look at the sky. The light that's actually hitting your eye is a messy combination of scattered violet, blue, green, and a little bit of everything else. It's a whole color recipe. But that specific recipe of light triggers the same response in our cones as a mix of pure blue light and just a little bit of white light. And that's the color our brain creates, sky blue. You know who got this? Isaac Newton, more than 300 years ago. He understood this profound idea that color isn't a property of light itself. Light rays aren't colored. They just have the power to make our brains create this sensation of color. The sky isn't blue, it just sends out light that our brains have evolved to see as blue. Wild, right? And you can see this exact principle playing out all over our solar system. If you change the atmosphere, if you change that recipe of light, you change the color of the sky. Let's take Mars. Its atmosphere is super thin, but it's loaded with big particles of reddish, iron-filled dust. And those particles are much better at scattering red light. The result? The famous pinkish-red sky you see in all the rover pictures. It's the same sun shining on both planets, but a different atmosphere gives you a completely different sky. And it's not just planets. Check out Saturn's moon Titan. It has this thick, soupy atmosphere full of these organic molecules called tholins. All that stuff in the air scatters light to create a constant, hazy, orange sky. Every time, it's the same rule. What's in the air makes the color. So, this all leads us to one last really mind-bending question. We've established that the sky's color is a team effort between the atmosphere and our eyes. So, what if our eyes had evolved differently? If our cones were sensitive to a different range of colors, what color would the sky be to us? The light from it would be exactly the same, but our experience, our reality, could be completely different. It's just an amazing reminder that the reality we see is something our own biology helps create.